I'm from Texas. I once was president of America. Hey, how you doing, guys? Proud to be an American. Hang in there, USA. We will get through this. Social distancing, washing, being healthy, and praying. Don't forget that. All right, hey, thanks for signing in here. We are going to do part 1 of missing angles. There's an angle. Well, let me get out of the way. Well, that's not a very good one. But anyway, there's an angle right there. Okay, we're going to talk about missing angles inside of shapes. This video is triangles. The one after this, part 2, will be quads, quadrilaterals. Okay, different rules. We're going to start with a few brief review vocab, just to brush up on the terminology we'll be seeing. And then we're going to jump right into an IXL lesson. And there's actually like 6 different levels on this one topic of missing angles and triangles. So we need to see all the ins and outs and ways you could be asked on a test question. All right, so let's jump into vocab.
All right, here we go. Angles and triangles, okay? Let's take a quick look. Y'all will remember this. Okay, so when you have that little square there, that means it's a right angle. Not like right left, but just that's equals 90 degrees is what that stands for, okay? Now, this is obviously, if we had 90 degrees, we can see this is less than 90 degrees. I'm going to put a less than symbol. It's less than 90 degrees. That word is called acute. So I tend to always think like if it's smaller than 90 degrees, I think of like a small cute little bunny or a cute little puppy. It's so small, it's so cute. Like everything small is kind of cute, right? Okay, and then lastly, when it's bigger than 90 degrees, okay, now it's greater than 90 degrees, the word is obtuse, okay? All right, so you will have some word problems that use some of these words. You have to know what they mean. All right, now, I always jokingly say triangle math. That's what we're going to be doing a lot of. Every triangle in the universe has how many interior degrees? So if you added up all of the angles on the inside of a triangle, okay? So if this is X, Y, and Z, if I figured out what those numbers were and I add them all up together, how much, class? Correct, 180 degrees. Now there's a cool way to figure that out. If you ever forget, let's pretend this is a square, okay? Those little tick marks means they're the same, okay? What do we know about a square? It has 4 right angles. How much is a right angle? How many degrees? We had it over here, 90 degrees. So 90 plus 90 is 180, plus 90 plus 90, another 180, is a grand total of 360 degrees, okay? But if I slice a triangle, out of it, I cut a triangle out of it, or I slice the square in half, same goes for any rectangle, okay? A rectangle has 4 right angles. You're going to end up with half of that 360 degrees, okay? Now I can't tell based on those angles, but what's half of 360 degrees? 180 degrees, okay? So you can work backwards and figure that out. All right, so let's look at the different types of triangles. Here we go. All right. Now the first one, if they have a tick mark on all 3 sides are equal, that means all the angles must also be equal, okay? And if all 3 sides or angles are equal, let's call one angle X. Well, since they're all equal, I could technically call them all X, okay? So basically, 3 times X must end up being 180 degrees. So if you divide both sides by 3, 180 divided by 3, every triangle that has 3 equal sides, they have to equal 60 degrees, okay? And this triangle is called a what? Equilateral, okay? because everything's equal. All three sides are equal. All three angles are equal. Okay? Now the next one is where only two sides are the same, and the corresponding two base angles would have to also be the same, or congruent is another one of our past vocabulary words. This triangle is called an isosceles. Okay? It's all coming back to you now, class? Okay. Now here, notice I have one tick mark here, two tick marks here, and three tick marks here. That means none of the sides are equal. And usually, you know, like a right-angled triangle over here is straight up and down. The isosceles makes a nice point like an arrow. This is perfectly symmetrical and everything. This is kind of leaning to one side. That's how I always remembered Scalene. Okay, that's what that triangle's called. And I already said this is a right triangle. Now, in any kind of triangle math, if they use an isosceles triangle, they could just tell you one of these and you could figure out the rest, or they could tell you the top and you could figure out the rest, okay? So I'm going to do two different colors. For example, if they said the top was 30, okay, well, there's 180 total. So 180 minus 30 is 150. Well, if I divide 150 in half, the bottom has to be the same, the two angles on the bottom. So that would be 75 and 75. Okay? So that's one way you could do it. Now, if they told me this angle was 30, well, then I know this has to be 30. So now I have 60 total. So I go 180 minus 60, and the top would have to be 100. Well, this triangle does not look like this, but it would have to have 120. 120. Can't see that very well. Okay, but you can see either way you could figure out the remaining angles. Okay, Scalene, they're going to have to tell you two angles. All three angles are different. Okay, but to finish on the right triangle, if they tell you 90, they could just tell you it's a right triangle and the top angle is 30 degrees. Okay? Well, if they say the word right, you know that's 90 degrees. Okay? So they only have to tell you one other angle of a right triangle. 90 plus 130 is 120. If I subtract that from 180, what's left? 60 degrees. Okay? So that's how we do triangle math, and that's some of the language we're going to be using. Let's get over to IXL.
Welcome back to triangle math. All right, we're going to jump over to IXL. Let me share the screen here and give it a moment, because it always lags for a minute when I first come to screen share. Let me see if I can. There we go. All right. So what I was talking about, triangle math in the notes. Let me pick a color here. Go with red. So I know every triangle in the universe, and actually there is a, I jokingly tell my students, can you think of a triangle, not even in the universe, but here on Earth, that is not 180 degrees? I could think of how to make one that wouldn't equal 180 degrees. We'll talk about that at the end. All right, so here, but for these, we'll have to give it away. For these two-dimensional triangles, okay, if you started at 3 locations on a sphere and connected them with straight lines, they're straight lines, so you're making a triangle, but because of the curvature, the angles are going to be off to some extent. So the degrees, maybe I should check on that somehow, but I don't believe they'll be exactly 180 degrees if they're curved. That's an interesting thought. We'll have to check that out. All right, so anyway, here we go. So let's get through these real quick. 180 degrees, all right? And I need to subtract those other two from 180, and that'll tell me what this missing one is. So first of all, I can see 4 plus 7 is 11. I'm going to carry the 1. So 3 plus 1 is 4, plus 5 is 91. Okay. Now I know 90 plus 90 is 180, but I'm 1 over, so the other number I'm going to need to get to 180 is 89. So that's what this one's going to have to be. Let's go pop that in there real quick. 89 degrees. And the degree symbol is already there, guys. So you won't have to mess with that. Wonderful. Okay, so now I'm going to go, I skipped to the next level. Sometimes my internet doesn't work when I'm using IXL and Zoom at the same time. All right, now, two of the angles in a triangle measure, see, they don't even have to give you a picture. You just know they have to total 180. So they're telling me one's 35 and one's 28. What is the measure of the third angle? So I always just, oops, let me get my pointer. All right, here we're back. So I always just, I'm a little lazy. I'll just write the 35 under the 28. Okay, 5 plus 8, that's going to be 13. Carry the 1, 2. 2 plus 1 is 3 plus 3 is 6. So I'm going to subtract that 63 from 180. Okay, I'm going to have to borrow from the 8 to have a 10 here. Therefore, that's going to change to a 7. Okay, I'm sorry, I was thinking ahead before I wrote the 63. This takes a long time to write. So 10 minus 3 is 7. 7 minus 6 is 1. And then I have a 117. So 117 degrees. Let's check it out, boys and girls. Oh, lovely. There we go. All right, now since I did that one, I can delete it. Let's go to the next level. We are now up to 65 score. A right triangle has one angle that measures 70 degrees. So they've told me it's right. So let me go back to draw. I need to draw. Let me get my trusty ink pen. If I draw it, okay. Okay. I get the general idea. They're telling me this is a right angle. There we go. So I know that's 90 degrees. And they told me one of the angles is 70. Okay. So 90 plus 70 is 160. If you subtract that from 180, because all triangles have to equal 180, then you're going to have a 20-degree angle left. Mouse, 20 degrees. Oh, that is outstanding. All right, let's move along. Next level. Go back to drawing and clear. All right, so now they're going to try to be a little different. Now there's multiple choice, but there could be multiple answers. So it's an isosceles triangle. So the first thing I need to know about isosceles, and it may not visually be exactly the type of angles they're telling me, but I'm just going to draw it like that to get a rough idea, okay? So it's an isosceles. Has an angle that measures 120. Which other angles could be in the isosceles triangle? Now, the 120, it's going to have to be the top, okay? Now look, if I put 120 on the bottom and another 120, because they both have to be equal, that's 240. That's more degrees than a triangle has. So I know I'll just use that little extra right there as my 1. Nice, okay? 120. Now, all triangles have to equal 180. So 180 minus 120 is 60 degrees. And each of the bottom angles has to be 30, okay? So that's the only option I have, all right? So for this, you click on it to highlight it as your choice, and then you hit submit. Keep it up, jolly good show. Moving right along. It's almost supper time. Need to get ready to eat dinner. Need to get these last couple problems done. So look, now we're to 74. 2 more to be at the challenge level here. One angle of a right triangle measures 25. What's the measure of the other? Well, this is the same. It's a different level, but it's the same as what we just did. So I know, or actually we did this 2 problems ago, right? I know one is 90 degrees. And then they're telling me the other one is 25. So let's say this top one is 25. So you add them together and subtract them from 180. So 90 plus 25 is going to be 115. 115er. I'm going to borrow from the 8 yet again. Thank you, 8, for always coming through for me. 10 minus 5 is 5. Oh, look at that. The 8 turns into a 7, not a 1. Stupid teacher. All right, 7 minus 1 is 6. And these ones will be gone. So 65 degrees. One problem left to get in the 90s. 65 degrees. Terrific. Terrific. Okay, close that. We're down to our last window. Clear this rubbish. And back to my ink pen. Now, this is similar to one we just did. Now, I chose this one for a reason, and I alluded to it 2 problems ago. In an isosceles triangle, I don't know if it'll be sort of ish. Okay. One of the angles measures 72. Which other angles could be in the isosceles triangle? Okay, well, let's find out. There's 2 possibilities here. Now, I told you last time they gave us like, what was it, 120, I think? And if you had 120 and 120 on the bottom, that'd be 240. That's too much. It's more than a triangle. It's 180. But now with the 72 that we're starting out with, it could possibly be the top. Look at that. I did that again. Or it might be able to be the bottom. Let's find out. Okay, let's see. So if it's the bottom, that means the other angle would also have to be 72. Okay, so mouse, I could have another 72. But then what's left? 72 plus 72 is 144. I have to subtract that from 180. And 8 is going to be our lender. We're going to borrow from 8 again. As long as we pay them back, they'll continue to lend to us. All right, so that becomes a 10. This is a 7. And 10 minus 4 is 6. 7 minus 4 is 3. So we have 36 degrees as another possible answer. So I'm going to go to my mouse over here. Double check on that one as well. That's why I specifically wanted to show you a problem like this, because it makes it sometimes where there's a whole lot of answers. Now, 180, if 72 is at the top, what's going to be left? Okay, and there's going to be 180 minus 72. It's going to be 8 degrees left. Okay, so there's 108 degrees left. Well, if I divide that in half, that will give me, woohoo, check that out, 54. All right, and there it is, right here. So there was 3 actual choices here. And we have reached the challenge level 92 degrees. Now, every programmer teacher is different. Our class, a lot of time, because of all the rigor, we stop at 92. We give them 100% if they can get up to 92. All right, guys, thank you so much for being with part 1. Now go check out part 2, quadrilaterals. Could be rectangles, parallelograms, etc. All right, let's do stop share and stop recording.